In this video, we're going to have a quick review of redox reactions, specifically writing redox equations. The first thing to recall is that redox reactions are made up of two half equations or half reactions. So one process is oxidation, whilst the other is reduction. The species that is oxidized loses electrons. It is also recognizable by an increase in oxidation number. For example, in this case, on the left, magnesium would have an oxidation number of 0, whereas on the right, it would have an oxidation number of +2. So we can see that it has increased from 0 to +2, indicating oxidation. If something is reduced, however, it gains electrons, and the oxidation number is decreased. So if we have a look in this case, the iodine, we've got 0, and over here -1. So we can see that the oxidation number has gone down, indicating reduction. You're also going to come across the terms oxidizing agents and reducing agents. An oxidizing agent is something that causes something else to be oxidized. Because oxidation and reduction always occurs in pairs, if the oxidizing agent is causing something to be oxidized, that means it itself is reduced. So in being reduced, it's going to gain electrons. And you'll sometimes hear oxidizing agents referred to as oxidizers or oxidants. Reducing agents, by comparison, cause something to be reduced. In doing so, they will be oxidized, which means they're going to lose electrons. You may hear oxidizing agents referred to as reducers or reductants. Now we'll have a quick look at the process to follow in order to write a redox equation. The first step is to identify the two redox pairs involved. And you'll recall that a redox pair shows the substance in its oxidized and reduced form. So basically what it's going to start out as before it reacts and what it's going to end up as. So in this example, we're going to look at dichromate ion, which will become chromium 3+ ion, and sulfur dioxide gas, which will be turning into the sulfate ion. Now the first step is always to balance the element, which isn't oxygen or hydrogen. So if we have a look at this first redox pair here, that's the chromium. So if we have a look at that, we'll notice on the left hand side that there are 2, which means we also need 2 on the right hand side. So I'll just put a 2 in there. If we have a look at our other half equation, we've only got 1 sulfur on each side, so we do not need to adjust that one. The next step is to balance the oxygen by adding H2O molecules. So if we have a look here, we have got 7 oxygen atoms, whereas on the right hand side we have none. So we need to balance that by adding 7 water molecules. Having a look at our other half equation here, on the left hand side we have 2 oxygen atoms, and on the right hand side we have 4, so that means we need to add 2 water molecules to the left hand side. Next, we balance the hydrogen by adding hydrogen ions. Looking at our first half equation, we'll see that we have 7 hydrogens on the right hand side and none on the left hand side. Well, sorry, 7 water molecules which each have 2 hydrogen ions. So that's going to be, hydrogen atoms. That's going to be 14 hydrogens on the right hand side. That means we need to add 14 to the left hand side. Looking at our other half equation here, we've got 2 lots of 2 hydrogens on the left, so 4 hydrogens, which means we're going to need 4 hydrogens on the right also. So we will add 4 hydrogen ions. Next, we balance the charge by adding electrons. If we have a look on the left hand side of this half equation, we'll notice we have got 14 positive charges. So I've got a plus charge and there's 14 of them. And then we've got a negative 2 charge. So overall, we've got a charge of plus 12. If we have a look on the right hand side, we've got 2 lots of plus 3. So we've got plus 6. So we need these 2 to be the same, and we're going to do that by adding electrons, which are negative. So we're always going to be bringing the higher number down to be equal to the lower number. So we need to bring positive 12 down to positive 6. So the difference between the 2 of those is 6. So we're going to be adding 6 electrons to the left hand side. Having a look at our other half equation, we'll notice there are no charges on the left hand side, which means that the overall charge is 0. If we have a look on the right hand side, we'll notice we've got a negative 2 charge and we've got 4 positive charges. So overall, we have a charge of plus 2. So we're going to need to reduce that down to 0, and we'll do that by adding 2 electrons to the right hand side. So in the previous step, you've ended up with 2 complete half equations. The next step in writing an overall redox equation is to combine the half equations. And we simply do that by adding them together. So the first step is to write them above each other. Now, before we go any further, I just want to point out something that's gone wrong in our previous step. Now, we worked out here that we needed to add 6 electrons to the left-hand side. And you can see that I've written them on the right-hand side. So we just need to remove them from there and add them on over here. And make the adjustments down here also. It's very important that you make sure your electrons are on the right hand side, well, not right hand side, but the correct side of your half equations, because when we're combining half equations, we'll always end up with electrons on the left hand side of one half equation and the right hand side of the other. And when we're combining the half equations, they'll cancel each other out, which is why we never see electrons in a normal balanced equation. Now, if we have a look in this situation, we have got 6 electrons on the left hand side of this equation and 12 on the right hand side of this. So what we're going to do to add these or combine these half equations is just add up everything on the left hand side here, add it all together and write it all in our overall, and the same on the right hand side. But before doing that, we need to make sure our electrons are going to cancel out. So we need to multiply one or both of the half equations by an integer so that we have the same number of electrons on each side. So in this case we've got 6 here and 2 here. So we need to times the 2 by 3, which will turn it into 6, so that we've got the same number and they will all cancel out. But that means we need to times everything in that half equation by 3. So I'm just going to rewrite that half equation after multiplying each term by 3. So now we can cancel out everything or anything that appears on both sides. So we've got 6 electrons on the left hand side and 6 on the right hand side, so they will cancel out. If we have a look, we've also got hydrogens on the left and the right. So we've got 12 on the right hand side, so 12 will cancel out from the left, which will leave us with 2. We have a look, we'll notice that we've also got water on both sides. So the 6 on the left will cancel out 6 from the right, leaving us with 1. So now we can write down everything that's left over to give us our overall equation. And now we have a balanced equation. The last step to do is to just count up everything on the left hand side and right hand side to double check that it is balanced.